Hello everyone, and welcome to today's presentation. I'm excited to have you here as we explore some key aspects of lighting safety and standards. Today, we'll be discussing the various factors that influence lighting safety, including dropping height, light duration, luminous intensity, and battery duration. We'll also look into the LSA Code, which specifies detailed requirements and minimum standards for lighting safety applications. So, stay with me as we go through what you need to know to ensure compliance and safety in your projects. Let's get started. Let's take a closer look at the equipment and their luminous characteristics. First, we have the life jacket light, which has a luminous intensity of 0.75 candela. This light should last for at least 8 hours, ensuring visibility over a significant period in emergency situations. The dropping height for this equipment is at least 4.5 meters without causing injury or damage, which is important for safety during deployment. Next, we have the Life Raft's external canopy light, which has a luminous intensity of 4.3 candela, and the internal canopy light with a slightly lower intensity of 0.5 candela. The external light is designed to provide visibility from a greater distance, at least 12 hours of operation, which is crucial for rescue efforts. The internal canopy light also lasts for at least 12 hours, but is intended for the interior of the raft, ensuring that those inside can see and move around safely. The dropping height for these components is specified at 18 meters, which means they are built to withstand drops from this height without damage, maintaining their functionality during critical moments. Overall, these specifications highlight how these devices are engineered for durability and prolonged visibility, playing a key role in ensuring safety and aiding rescue operations in emergency situations. Let's take a closer look at the equipment and their luminous intensities, light durations, and dropping heights. First, we have the lifebuoy that is self-igniting, which is quite crucial in emergency situations. It emits a light with a luminous intensity of 2 candela, and this light lasts for about 2 hours. When deploying it, you should drop it from the lesser of the stowed height or 30 meters, ensuring it functions properly without risking damage from excessive height. Next, we have the lifeboat external canopy light, which is slightly brighter with a luminous intensity of 4.3 candela, and it's designed to last at least 12 hours. This prolonged duration is vital for rescue operations, giving rescuers ample visibility. Inside the lifeboat, there's an internal light with a luminous intensity of 0.5 candela. Although it's lower in brightness, it also lasts for at least 12 hours, providing consistent illumination inside the vessel. The dropping height for these internal lights is about 3 meters or roughly 10 feet, which is a standard safe deployment height to ensure the light remains operational while minimizing risk. Overall, these lighting equipment are carefully designed to ensure visibility, safety, and durability during rescue scenarios, which ties directly into our overall focus on safety preparedness at sea. Let's take a closer look at the different types of signaling equipment and their key characteristics. First, we have the man overboard marker, which typically has a luminous intensity of about 2 candela. This means it emits enough light to be seen clearly in the dark, and it can last for around 2 hours. Additionally, it produces smoke that lasts for at least 15 minutes, which is helpful in foggy or low visibility conditions. The dropping height for this marker should be the lesser of the stowed height, or 30 meters, ensuring it deploys effectively without risking damage or inefficiency. Next, we have the rocket parachute flare, which is much more intense, with a luminous intensity of about 30,000 candela. This flare burns for approximately 40 seconds, providing a bright, visible signal from a considerable distance. Its high intensity makes it ideal for alerting rescuers or signaling your position over long distances. Overall, these devices are designed to maximize visibility and signal clarity in emergency situations, aligning with our overall focus on safety and effective rescue procedures. Choosing the right equipment depends on the specific circumstances, including visibility conditions and the distance to rescuers. Let's take a closer look at the different equipment we might use in various situations. Starting with the hand flare, which has a luminous intensity of 15,000 candelas and lasts for about 60 seconds. This makes it very bright and effective for quick signaling, especially in emergency scenarios. Next, we have the smoke float, which, interestingly, has zero luminous intensity, meaning it doesn't produce light, but it lasts much longer, up to 180 seconds. This can be useful for creating visual markers or obscuring vision in certain situations, even without illumination. Finally, there's the searchlight. It has a luminous intensity of around 2,500 candelas, but can operate continuously for about 6 hours, with a total period of 3 hours of active use. That extended duration makes it ideal for sustained searches or ongoing visibility in larger areas. Connecting this to our overall theme, understanding the different capabilities of each piece of equipment helps us choose the right tool for the right situation, balancing brightness, duration, and purpose to maximize safety and effectiveness. Now, let's take a closer look at the equipment details related to their luminous intensity and battery life. First up, we have the EPIRB, or emergency position indicating radio beacon. It has a luminous intensity of 0.75 candelas, which might seem modest, but it's designed to be effective for emergency signaling. Its battery life allows it to operate for approximately 48 hours, or about 2 days, ensuring it can transmit distress signals long enough for rescue teams to locate you. Moving on to the SART, or Search and Rescue Transponder, the key point here is its impressive standby duration. When it's in standby mode, it can last up to 96 hours, which is 4 days, providing a reliable window for search operations. However, once triggered by a nearby radar, specifically a 3-centimeter radar, it becomes active and can operate for about 8 hours. This quick activation capability is crucial during rescue scenarios, making sure that the distress signal is transmitted promptly when needed. Overall, these figures highlight how these devices are engineered for reliability and endurance in emergency situations, aligning perfectly with our overall focus on safety and preparedness at sea.